split this middle term now into those two numbers, and it makes a difference which number is negative. So in this case, 3 was negative. So we have x squared. It doesn't really matter if you put the 4 or the 3 first. That doesn't matter. 4x minus 3x minus 12. Now we look at the first two terms and look at the next two terms and see what's common. Well, x squared and 4x, x is common, and negative 3x and negative 12, the number negative 3 is common. So we're going to divide by these values. So remember, this thing goes in front, so we have x in front. This is called factoring. So this is the difference between factoring and just dividing. Dividing, you just divide. Factoring means you're technically dividing, but then you're using that thing that you divided by and putting it in front of that bracket. So x squared divided by x is x. 4x divided by x is just 4, so we have x plus 4. Here we're dividing by negative 3, so negative 3 comes in front of that second bracket. And what's negative 3x divided by negative 3? Well, that's just x. And what's negative 12 divided by negative 3? Negative divided by negative is a positive number. That's positive 4. And guess what? You know you're doing it right if the brackets are exactly the same. Now, if you're at this step and the brackets aren't exactly the same, you probably made a mistake somewhere in the previous steps. So I would recommend going back and fixing that if you have time. All right, and then here we have x minus 3, which is the other bracket there. That's the answer. That is how you factor a simple trinomial. Yeah, I guess we're doing more practice. Okay, yeah, I think I might go a little bit quicker. These ones. Okay, same thing, A, B, C, A, B, and C. A being 1, B being minus 7, C being 10, obviously. So we're looking for two numbers that add up to negative 7, and the same two numbers that multiply to 10. So we look at our product here, which is 10, and we do 10 divided by 1, which is 10. 10 divided by 2, which is 5. Now we do divided by 3. And notice that 10 divided by 3 is not a whole number, it's a decimal. So we skip it. We don't care. 10 divided by 4, well, that's also, it's going to be 2.5. But 2.5 is a decimal, so we don't like that. Skip. So you only write the whole numbers because we're looking for proper factors, right? We're not looking for decimals here. 10 divided by 5 is 2, and guess what? At this point, I can stop because the 2 and 5 and the 5 and 2 are repeating. So really, there's only these 4 factors of 10. And these only 2 sets of pairs. So 1 and 10 and 2 and 5. Here we have a negative 7. What does that mean? Because 1 plus 10 is 11 and 2 plus 5 is 7. But look, 2 plus 5 is 7. That's close to negative 7, kind of. What you'll learn is that in this example, instead of one factor being negative, you can also have the possibility of both factors being negative. What does that mean? That means I can have negative 2 and negative 5. Because negative 2 plus negative 5 is negative 7. And negative 2 times negative 5 is still positive 10. That's important there. So the correct answers and the correct set of pairs are 2 and 5, except, they're negative versions. So now that I have that, what I'm going to do is I'm going to split that middle term there. We're going to have x squared. No, minus 7x, so minus 2x minus 5x plus 10. And once again, we are dividing the first two terms and then dividing the last two terms. First two terms, are divided by x and any common number factor, but there is nothing. And as for the last two terms, you're not dividing by x, but you're dividing by -5 in this case. I'll give you a hint. Like 90% of the time, the second bracket, you're usually dividing by the value that's right here. Like here, in this position. And if you take a look at that, that's been true for all these examples here. This is -3, -3. And this is 3 and 3. So like 90% of the time, that's usually what's happening. You're dividing by that value there. Anyways, so this x goes in front there. So we have x times x squared divided by x is just x. And we have -2 here. Because -2x divided by x is just -2. Here we have -5, because that's what's down here. And -5x divided by -5 is just x. And 10 divided by -5 is -2. Once again, you know you're doing it right if these two brackets are exactly the same. X minus 2. And then x minus 5. And that's the answer. Thank you. Alright, here we have a 1 here and a 1 here. Don't forget that. So your b value is -1 and your c value is -20. So m plus n is equal to -1 and m times n is equal to -20. Now we're just going to take 20 divided by 1. We know it's 20. Divided by 2. Oops. Is 10. Divided by 3. Guess what? Doesn't work. Divided by 4, which is 5. And divided by 5, which is 4. So this step, you're just using a calculator, remember. And we know I can stop here because 4 and 5 and 5 and 4 are repeating. That means the only possible combinations are 1, 2, or 3. Oh, thank you. Delicious. So it could be 1 plus 20, that's 21. 2 plus 10 is 12, and 4 plus 5 is 9. Obviously, none of those work because you have a negative number here. What that means is one of these factors has to be negative, because the only way you can get a negative number by multiplying two numbers is if one of them is negative. Burger. Burger. So we can either have 1 minus 20 or 20 minus 1. Either way, that doesn't equal -1. 2 minus 10 or 10 minus 2. Same thing, you're getting like 8 and -8, so that's not working. What about 4 minus 5 or 5 minus 4? Well, 4 minus 5 is -1. Delicious. And 5 minus 4 is +1. So we are looking for the -1 version, so it's not this one. It's going to be 4 and -5. So my two numbers are 4 and -5. And 4 times -5 is -20, and 4 minus 5 is -1. So this makes sense. Delicious. Oh. It's cold, Daddy. It's cold. It's cold? Oh, it's okay. Eat it. It's cold. So in this way, we're gonna. Okay. I'm gonna show you a nice little trick here now. Trick is this. See these values, -2 and -5. -2 and -5. Our two values are 4 and -3. 4 and -3. Here we have our two values are 2 and 3. X plus 2, X plus 3. So there's a shortcut method that you can use. and it only works for when your a value is 1. So this is why it's dangerous, because if your a value is anything other than 1, this will never work, and you will get absolutely 0 marks for this if you were to do this. And students do this all the time. But this is a shortcut method. Once you find your two numbers, you can make your two brackets, and all you have to do is x, put the first number. If it's positive, you do plus sign. If it's negative, you do a negative sign. That's the answer. And that's a nice little shortcut. Oh, thank you. Okay. So let's move on. Alright, so now we're going to learn a different type of factor. So we're going to learn a different type of factoring now called the difference of squares. Difference of squares is a special case. You only have two terms here. A squared minus B squared. There's no C, ABC, something like that. It's different. It's unique, and we're going to, this is what it means. A squared minus B squared equals, the two brackets are A plus B and A minus B. How does that look? Easy. Here, this is an example of A squared minus B squared. How? Well, the A squared is the X squared here. That's pretty easy. But how's the 16B squared? Well, 16 is one of those special numbers. And I'll show you what these special numbers are. So we have 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. I mean, it keeps going on, but for our examples, we don't need to know much more. You guys can figure it out. So that's 1, 4, 9, 16, 25. Sorry, 16. These are called perfect squares. I mean, you can keep going. 6 squared, 7 squared, 8 squared, 36, 49, 64, and so on. So very easy to figure it out with a calculator. So 16 is one of these special numbers. That means I can rewrite this as x squared minus 4 squared. Now it looks like a squared minus b squared, right? A is the x, the square is the square, the b is the 4, and square is square. So if my formula is a squared minus b squared is equal to a plus b times a minus b, I can very easily simplify this as, since my a value is x, x plus, and my b value is 4, x plus 4, x minus 4. And that's how you factor this. So it's a special case. It's called difference of squares. Whenever you have two terms and they're subtracting, always think of difference of squares. There's a very good possibility it could be difference of squares. I'll do more examples so you guys can get a better hang of this. Here we have x squared minus 25. X squared minus 25. Now, is 25 one of these special numbers? It is one of these special numbers. So I know that I can rewrite this as x squared minus 5 squared. I didn't change anything. 5 squared is 25. I'm just rewriting it in a way that's easy for me. And then I know for a fact that this is going to be x plus 5, x minus 5. And that's the answer. And we're going to do another example now. X squared minus 64. We know 64 is right over here, 8. So this is rewritten as x squared minus 8 squared. And this can be now written as x plus 8, x minus 8. That's the answer. A few notes, pointers that you should know. Difference of squares cannot be done if the original question is x squared plus 16. Even though they're both, squares. That's 4 squared, that's x squared. Because it's a plus sign,